green hydrogen will play an important role in the energy transition necessary for a better environment. It is believed that green hydrogen could cope up to 12% of the total energy needed by 2050. That's one of the main reasons why many countries have put in place ambitious plans to increase their green hydrogen production. South Korea is one of those good examples. South Korea is planning to increase the hydrogen use in the energy sector by 10% in 2030 and up to 30% by 2040. Not only that, they are also planning to deploy approximately 200,000 vehicles that are using fuel cells powered by green hydrogen. But we have to be mindful that renewable energy sources are going to be needed in many other sectors, and therefore optimizing the electrical ecosystem around the green hydrogen industry is a must. We at KraftPowercon see the opportunities, but also understand the complexity of the design and the challenges that the industry will be facing by scaling up and increasing demand. My name is Raul Montano. I'm the portfolio manager and energy expert at KraftPowercon, and I would like to walk you through some of these challenges and considerations that the industry needs. One of the key elements of green hydrogen production is to have access to renewable energy sources, irrespectively if it is wind, solar, hydro, or tidal. You wish to have your energy source as close as possible to the hydrogen installation. In that particular sense, solar and wind are the most predominant technologies coping with such a technical requirement. But that comes to the expense to have a more fluctuating energy source. To cope with that, the most common industry practice is to double the size of the hydrogen installation. For example, if you wish to install 1 megawatt of hydrogen production, you will need to install at least 2 megawatts of energy sources. How does it impact my project? As simple as by having an oversized energy source installation, you will need to get a more attractive or less attractive project from the size of the investors. And what happened with the energy surplus? Conventionally, this is just fed back to the grid. But what if we could design the overall plan around the hydrogen installation to be more flexible? What if our hydrogen installation have the capability to absorb that part of the energy that in principle is fed to the grid? Why we don't use hydrogen as an energy carrier? In many cases, even they have been considering to install battery banks. Why don't we try to design the system in a sense that we could store the energy in the hydrogen? By doing so, and potentially reducing the oversize to 1.2 to 1 or 1.5 to 1, the overall investment and the economy of the plant will be more attractive to your investor and will speed up the requirements at the moment of realization of your project. At this point, you might be wondering, why are we talking about an ecosystem? And why this ecosystem is such an importance? If we take a simplistic approach, we might think that there are only few components that you need to feed up or power your hydrogen installation. You might need a power transformer. You will need some kind of filtering source to ensure the power quality on the output. You will need the power supply and some extra components to cope with your output requirements towards the hydrogen installation. But that is like riding a bicycle. If you're riding your bicycle solo, it's quite simple. It's only yourself. But now imagine if you have a bicycle that potentially have two-seated or a five-seated bicycle. You will need to really synchronize with your different peers to optimize your performance in the race. Now imagine if among those you put few hundred of these different cyclists working together towards a common goal. That is the challenge that the hydrogen industry will start facing when they start scaling up. Until now, most of the installations are on the couple of megawatts range, maybe up to 100. But we need massive amount of energy. It means this will scale up to few hundred of megawatts or to the gigawatt scale. And now it's not any longer one simple component to be fed off. It's not the same trying to speak in a party of one than you have a party of 500, or in a concert where you have a couple of hundred of thousands of people together. We need to look around and look how we could optimize this ecosystem in a sense that all the different components are in synchronism and have the least impact towards the network and have the maximum energy use towards your hydrogen installation. We understand that the need for greener energies and technology is a global issue. We also understand that the hydrogen installation could be part of different processes. For example, you might not need to have the same requirements if you're going to install your hydrogen installation in the Americas, in Europe, in Asia, or South America. You might need, or you might have access to different energy sources. For example, in Middle East, you could have plenty of solar energy. In the Americas, in Europe, you might have a lot of wind energy. So all these come with different technical requirements, but more importantly, local requirements, irrespectively if they are based on the same international standard. At the same time, you might need to consider where is my hydrogen installation, not only geographically, but physically. Is it in isolation, in a remote place where I have full access to renewable energy sources? Or is it within an industrial plant where my hydrogen installation is part of a process? Does it need to be fed 24/7? What will be the impact if my hydrogen installation have a downtime? Will it be local or will it be affecting the overall industrial process? At the same time, if it is an industrial facility, do you have access to any other electrical infrastructure? Do you need to have such a refined requirements towards the network, or could you be more flexible? In that particular sense, it is really important that we understand the needs for the different components in different situations. If you are in an industrial facility, very likely you might already have installed components that are taking part of the filters and the performance towards the grid. So in that sense, you don't need a refined power source to power your hydro installation. But if you are in isolation, where potentially the grid might be weak, or you are purely or fully powered by renewable energy sources, you might need to consider a very refined and high technological power source. At this point, many of our colleagues and competitors might be disputing whether one technology and power source is better than the other. You might hear about IGBTs and thyristors. One is better, the other is the ancient. But in reality, what matters is, where is my hydrogen installation? What are the requirements? What are the impact towards my technology? Does the ripple really have an impact toward the quality and the lifetime of my plant? All these factors need to be considered. If I go back to the same example of the isolation versus industrial plant, for me, it's like if I'm in an industrial plant where I don't need a high level of refinement in terms of energy quality, it's like having a Ferrari when you can go further than 20 kilometers or 20 miles per hour. In that particular case, a small car, a Fiat Punto, it could do the work. But when you are in isolation, when you have a weak network, when you have a lot of fluctuation, there is where you need to consider in details what technology to choose. It's not about technology. It's about to understand the overall environment, the regulation, so at the end of the day, you can optimize the performance of the plant as well as your investment. Scaling up is not only impose requirements in terms of energy. Also, a lot of importance is given to the economical part. But is it really the economy? Is it really how much I pay for my installation, what I need to look for? Let me give you a couple of examples. Imagine you are in a region where your energy or electricity cost is really high. We have to be mindful that in the green hydrogen production, about 70% of the operational cost is associated directly with the energy price. So, will it not make more sense potentially to have a bigger investment, but to get access to a system that imposes a higher efficiency? So at the end of the day, when you look on the overall economy of the plant along the lifetime, you will get a bigger revenues. That's not the case when you have really access to a very cheap and low-cost energy source, green energy source. In those particular cases, maybe an increase of 1 or 2% in the efficiency will not pay off to have a costlier and refined energy source upfront. What about health and safety? You can sacrifice health and safety by making affordable installations that need to be thoroughly considered, irrespectively whether if it is a high-end or high-cost energy region or a very low-end or very low-cost energy region. We also discuss about having our installation in isolation or being part of a production plant in a production process. In that particular case, maybe I will need to have a larger investment, but to ensure that I have true redundancy feeding or powering my hydrogen installation, because the impact of having a downtime in terms of the hydrogen production, it will have a much larger impact and consequences along the whole production facility. But if it is only myself, maybe I don't need to pay for such a refined or a good, efficient, and high reliable source. Is it a pilot project, or is it an industrialized project? All these different factors naturally need to be considered when you're going to scale up. It will not be the same losing 1 megawatt from the grid when you're going to be losing 1 or 2 or 5 gigawatts. How you could design the overall system in such a manner that, considering the economical part, the operational costs, the health and safety requirements, could optimize the production, extending the lifetime of your facility, and improve the economy of the overall project. When we're talking about scaling up in the industry, very often we concentrate in the technology that's going to be used. Naturally, the majority of the people working in this environment are engineers, and they're very technical oriented. You might have here at this point, it's going to be PEM technology or alkaline because it's quite robust and stable. Maybe it will be SOEC because it provides a quite good efficiency. But at the same time, all the different technologies, they have different technical challenges. For example, if we're talking about alkaline, the most robust one, that's not that sensitive to the power quality output. Maybe the SOEC, which is quite sensitive to start-stop processes, or the PEM, where you have a polymeric membrane in an electric field, which is quite sensitive to the voltage fluctuation. Those are technical parameters that very often you consider when you are designing your plan. But what about the political scenario? Do you have access, potentially, to green certificates that could be trade-off? Is there any incentive in your country or region that it could potentially improve the economy of the overall project, and therefore reducing the return of investment or increasing the revenue? What about the local requirements? Is it close to a sensitive installation and therefore you really need to consider the power quality? So, as one can see, it's not purely about technology. It's not pure about one or the other. You also need to look around and understand the geopolitical arena where your installation is going to be, the local requirements, the network, and more importantly, your hydrogen installation. Because at the end of the day, we need to make good use of all the different resources: economical, political, and natural resources. I hope at this point I managed to explain you and walk you through briefly around few of the challenges, difficulties, and complexities that the green hydrogen industry will face while scaling up. At the end of the day, we are all here together in the energy transition necessary for a better environment for the future generations to come. You might be thinking that we all energy ecosystem suppliers might look alike, but very few will really sit down and dare to help you to do the right things to standardize before you scale up. Please talk to one of our representatives. We will be delighted to help you to overcome this challenge together. I hope you enjoyed this brief introduction, and thank you very much for listening.